Hello students. So welcome back to the reasoning class. So let us continue to the next topic. The next topic is odd man out series. Now, in this concept of odd man out series, we will be removing odd man out, which is not related. So, you are expected to have some understanding about what are the questions that are given. These are going to be easy. You can come out with a wild guess for few, but then you're supposed to analyze the questions so that you will get the right answer. Okay, so you have to be familiar with the words of a few of the things. So, and moreover, as I already told you, it's going to be easy. They will not question you in a very deep way, because the focus is not to have a competitive exam, but then to also give you or make you understand that yes, these problems or these type of questions are also being asked in all the competitive examinations. So let us see what kind of questions can we get under odd man out series. So first one, they'll give the options and they'll ask you which is the odd man out. Here we have given some frequently asked questions and it's very simple to do is what they say here. So let us see. Curd, butter, cheese, oil, cream. So these are the five options and we are supposed to eliminate oil. Why is that? Let us analyze. Curd is a product of milk, right? Butter is also a product of milk. Cheese is also a product of milk. Cream is also a product of milk. But oil is not a product of milk. Oil can be extracted from seeds, right? Sunflower, and you can have rice bran. So it's not part of the milk products or dairy products. So oil is the odd man out. Now let us see the next question. Rose, lotus, marigold, lily, tulip. Now, rose is grown on land. Lotus is a water plant. You can see lotus where? In the water. It either in the river or no, actually it will be in the lake, because in the flowing water you cannot find lotus. You're supposed to have a stagnant water. Okay, so you can find lotus in the lake. Marigold, that will also grow on land. Lily is also growing on land. Tulip is also grown on land. So, except lotus, all the other flowers are grown on land. So, lotus is the odd man out. I hope you're able to understand. Then, pistol, sword, gun, rifle, cannon. Now, if you see here, pistol is a type of gun. Gun, again, it's a gun. Rifle also is like gun. Cannon is that you can see that it's a bigger type of gun, but then you put that uh, dynamite into it and then it will come. It will be something like this. You have the machinery here, and it will have a tunnel like this where you can fire the either a bomb or the rifle or the firework or the firearm that you can fire from there. So it is usually used in the military cases. So that will be a cannon. Now, out of all this, if you see, you will see the sword. Sword is the traditional technique. So that is not a firearm. You don't use fire. Now in gun you have a bullet. Okay, in pistol also you have a bullet. So it's a fire arm that has been used. So except sword, rest all of them are firearms. Next, cathedral, mosque, church, monastery, and temple. Now, cathedral is a type of church or where they worship. Okay, mosque is again a place of worship. Church is also a place of worship. Cathedral, church are almost similar. Temple is also a place of worship. But monastery is the place where the monks will stay. Now in Indian language you call it as matha. That is monastery. So monastery is a place where monks will stay. So except monastery, rest all are the places of worship. Then Poland, Greece, Spain, Italy, Korea. Okay, so these are the countries that has been given. Poland, Greece, Spain, Italy, and Korea. So these are the options given to us. Now, to answer such questions, you have to know, about the countries which are in Europe, or states of few countries like that. Okay, so because it's a preconceived notion that we have learned world map from schooling, so that's why you can expect such questions. So Poland, Greece, Spain, Italy, all are part of European countries, but Korea is a Asian country. So Korea is odd man out. Then copper, tin, brass, platinum, zinc. Now here if you see, uh, this also you require a little knowledge about the metals. If not, you can just work out more problems to understand. So copper, tin, okay, it says here all except brass are metals, while brass is an alloy. Okay, so these are direct metals. Copper, tin, platinum, zinc are direct metals, but brass is a mixture of two or more metals. So that is why it is called as an alloy. Okay, so brass is a mixture of two or more metals. When you mix two or more metals, it is called as alloy. Okay, so these are the few questions which you can expect for odd man out series. You can work out more questions out of these series to understand things better. Okay, I hope you all understood odd man out series. Okay, so the next concept is time and work. So we are supposed to understand about time and work. Now, if you see here, before starting, let's understand few facts and formulas that will help us in understanding the complete concept. So, if A can do a piece of work in 9 days, then A's 1 day work is denoted as 1 by n. So, if they say A can do a piece of work in 10 days, then in 1 day he can do 1 by 10 work. Okay, he can do 1 by 10th of the work in 1 day. So that's what they are trying to say. So they'll usually give you, if A can do work in 10 hours, 5 hours, 15 days. So in those cases, here they have specified it as number of days. So in that case, 1 by 10, that will be the 1 day's work. Then if A's 1 day's work is 1 by n, then A can finish the work in n days. This is the opposite. If A's 1 day work is 1 by 10 in our example, so A can finish the work in 10 days. Okay. Then if A is thrice as good as the workman as B, then the ratio will be 3:1. So we have solved enough ratio problems. So you can apply ratio because they are saying thrice, which means 3 times. Okay, if A is thrice as good, so 3 times. Then ratio of times taken by A and B to finish the work is 1:3. So if they are talking about thrice and twice and all, you can take the ratio there and you can solve the problems. So these are few of the important facts and formulas that you are supposed to understand. Now let us directly solve the problems. Okay, so the first problem, let us see what is there in the first problem. Worker A takes 8 hours to do a job. Worker A takes 8 hours to do a job. Worker B takes 10 hours to do the same job. How long should it take both A and B working together but independently to do the same job? Okay, so here what did we learn before? If A can do a piece of work in n days, then A's 1 day work is 1 by n. So if A takes 8 hours to do the job, if A is taking 8 hours to do the job, so in 1 day, sorry, in 1 hour, 8 hours he will take to complete the job. So in 1 hour, he will be able to do 1 by 8 of the job. Okay, this is for A. Now similarly for B, if he is taking 10 hours to finish the job, so in 1 hour, he will be able to do 1 by 10 of the job. Okay, so they are saying A is taking 8 hours to do the job, B is taking 10 hours to do the same job. So 10 hours to complete the job, but for 1 hour he's going to complete 1 by 10. A is going to complete 1 by 8. So how long should it take for both A and B working together but independently to do the same job? So here, since we have understood 1 by 8 and 1 by 10, now since the A and B are working together, so A and B's 1 hour work is nothing but 1 by 8, that is A's 1 hour job, plus 1 by 10, that is B's 1 hour job. Now if you take the LCM here, you can directly just multiply this and you can write 10 plus 8. So 18 by 80, or you can cancel this out. 2 4s are 8, 2 9s are. Okay. So 9 by 40. So that will be A and B together. If they work together but independently, that will be the job of A plus B. Fine. So let me revise it once again. So firstly, A is gonna take 8 hours to complete the job. So 8 hours to complete total job. So 1 hour, in 1 hour he can complete 1 by n, that is 1 by 8 job. Then for B, he's gonna take 10 hours to complete the job, but for 1 hour he's able to complete 1 by 10. Now then they are saying A and B are working together. So A and B for 1 hour, how much they will work? They're going to work for 9 by 40. Okay, so this we have to get it. Now let us find out how much days or time they will take to complete the job. This was for 1 hour. Right? This was for 1 hour. Now what we will do? if A was able to finish the job in 8 hours, for 1 hour we took it as 1 by 8, right? So before it was 8 by 1. So now reverse this fraction. Now total job, how will they complete the total job? 9 by 40 was for 1 hour. Now full 100% you'll have to reverse. 40 by 9. Okay, 40 by 9. That is how we will do. Or you can take it as a rule saying reverse the fraction, so that will be easy for you to remember. Okay, now this 40 by 9, if you divide 40 by 9, you get 4.44 days. Okay, so A and B together will finish the job in 4.44 days. I hope that is clear. That's what they asked us. How long will it take for them to complete the job? So it will take 4.44 days for both A and B to finish the work. So this is your time and work. So one thing what you have to understand is this rules. Okay, I hope it is clear to everyone. Now let's go to the next question. A and B are working together. A and B together can complete a piece of work in 4 days. If A alone can complete the same work in 12 days, in how many days can B alone complete that work? So here what is happening is, first A and B can complete the work in 4 days. A plus B together, if they work for 4 days, they can complete the work. This is first situation. Now the second situation is A alone is working, only A is working, and he is taking 12 days to finish the work. Now third situation, what they are asking us to find is, if B is working alone, how many days or how many hours will he take to complete the work? Okay, so that is the question. If A and B together they are working, 4 days is enough to complete the work. If A alone is working, he requires 12 days. If B alone is working, how much days he requires? So if A plus B, if A plus B are taking 4 days to complete the work, so for 1 day, they will be working 1 by 4. 1 by n. Okay, so they will be working 1 by 4. Fine. Next, A is completing the work in 12 hours. So A requires 12 days to complete the work. So for 1 day he is gonna do 1 by 12 of the work. So A plus B together is going to do 1 by 4 of the work in 1 day. And A alone is going to finish 1 by 12 of the work when he is doing it alone. Fine. Now here what we will be doing is A plus B minus A, because we know the value of A, minus A. If we do, this will give us the B value. A plus B is the total number of days. Out of that, if I subtract A alone, then I can get B alone days. So that is the logic here which we are using. So A plus B, 1 day's work is 1 by 4, and A if he is working alone, he is finishing 1 by 12. So to get B's alone 1 day's work, we will subtract A plus B minus A. A plus B is 1 by 4, minus A is 1 by 12. Okay, now you can find the LCM here. 12 and 4. 2 6 are, 2 2s are, 2 3s are, 2 1s are, 3 1s are, 2 2s are 4, 4 3s are 12. You can take this as 12. So 4 3s are 3 minus 1. 2 by 12. The LCM will be 12, and then 3 minus 1, which is 2 by 12. So 2 ones are 2 six are. 1 by 6 will be the B's 1 day work. 1 by 6 is the B's 1 day work. How did I get that? I calculated the LCM here, and then I simplified it to get the answer. So B alone is going to take, now this is 1 by n, which means now B is going to take 6 days to complete the work alone. He is going to do the work alone for 6 days and complete the work. So B can complete the work in 6 days. Okay, so this is the next type of question. Now let's go to the third question. A can do a piece of work in 7 days of 9 hours each, or this is actually for 9 hours, no problem, of 9 hours each, and B can do it in 6 days of 7 hours each. How long will they take to do it, working together 8 2 by 5 hours a day? Okay, now you have days and hours. 7 days, for all 7 days, he's working for 9 hours a day. So here, instead of considering the days, you have to consider the hours by multiplying both of them. Okay, for 7 days, he is working for 9 hours, which means he is totally, who is that? A is totally working for 63 hours. And then if you take up B is taking 6 days. Okay, B is taking 6 days into 7 hours each day. So he is working for 42 hours. 6 sevens are. Okay, so the total number of hours here is 63 and the total number of hours for B is 42. Now this is their total working hours. Now for 1 hour, how will I find? If this is n, for 1 hour, it will be 1 by n, which is 1 by 63. So A's work or A's job for 1 hour is 1 by 63 and B's job for 1 hour is 1 by 42. So much is the first derivation. You have to multiply the days into hours so that we get the total working hours of A and total working hours of B. And then we convert that to 1 hour conversion so that we will understand for 1 hour how much they work. Now let us see the question. How long will they take to do it working together? Working together means A plus B. Working together means A plus B. So 1 by 63 plus 1 by 42. If you take the LCM and calculate, you will get 5 by 126. That is the work that has been completed in 1 hour when A and B work together. When A and B work together, they're going to complete it within 1 hour. How much work? 5 by 126 work will be completed. Now this is for 1 hour. Now let us take the total work. Now when it comes to total work, what did I say? You have to reverse the ratio. Correct? You have to reverse the ratio. So when you reverse the ratio, it is going to become 126 by 5 hours. 126 by 5 hours, and then this will be 126 by 5 hours has to be considered with the question. Now firstly, I hope you all understood until 126 by 5 hours. So, firstly, 63 is the total number of hours required by A, 42 is the total number of hours required by B. Now, in 1 hour, A is able to complete 1 by 63 of the job, and in 1 hour, B is able to complete 1 by 42 of the job. Now, if they work together, they are able to complete 5 by 126 of the job. So both will be finishing the work in 126 by 5. How did I get it? By reversing the fraction. Now, if you go back to the question, how long will they take to do it? Working together 8 2 by 5 hours a day. Now, let us convert that mixed fraction. 8 2 by 5 is nothing but 5 into 8. 8 5s are 40 plus 2 by 5. So 42 by 5. Okay. So this again has to be reversed. So you get 126 by 5 into 5 by 42, which will give you 3 days. So both A and B are working for 42, 8 2 by 5 hours every day. Okay. And we have understood. So now A 42 by 5 is N. Then 1 by 42 by N. 1 by 42 by, okay, let me clear this. If 42 by 5 is equal to N, then 1 by N is 1 by 42 by 5, which is nothing but 1 into 5 by 42. Right? So that is why we change or reverse the fraction and we multiply it with this and we get the answer as 3 days. The working has to be practiced a little and then you'll be able to solve these problems easily. Always remember, if a total number of hours or days is given, convert that to 1 hour or 1 day, and then you can check if you have to add, multiply, divide, subtract, all that you can check later. Okay, so this is your time and work problems. There are more problems under this where you can solve it out, but the variety will be more or less similar to this. I hope everybody understood. So this will be the time and work problems. Okay, the next concept is number series. Okay, you don't have ranking and time sequence and all. Okay, this part is not present. Ranking and time sequence is not there. We are only going to learn the number series or the number test. Fine. So let us start. Okay. In this type of questions, generally, you are given a long series of numbers. The candidate is required to find out how many times a number satisfying the conditions specified in the question occurs. So let us directly get into the problems so you'll be able to understand it. How many fives are there in the following sequence which are immediately followed by threes but not immediately preceded by 7? Okay. So here what is happening is, first let us understand what is the question. How many fives are there? So they're asking how many number 5 is there in this series. You can see these numbers here, a long sequence of numbers. Okay, so how many fives are there? And there is a condition. What is the condition? That it is immediately followed by 3. Followed means next to 5 there should be 3. And but not immediately, it should not have 7 before 5. Okay, it should not have 7 before 5. Now let us see where all we'll get this. So there is a 5 here, and that 5 has a 3 after it, and it does not have a 7 before it. Okay, so this is eligible. This I can consider. So I got 1, 5. Now see the next one. Again, there is one more 5 here, where after 5 there is 3, but before 5 there is no 7. So there is one more which I got. So 2 5s I have got. Now let us go to the next 5. You see here there is the third one. Now after this 5 there is a 5, but there is no 3. Right? So I cannot consider this. Next again I have a 5 here. Now this 5 is, the next number is 7 and the previous is 3. So there is no meaning. I cannot consider. So what is the rule? You need to have a 5. The next number of 5 is 3, and previously you should not have 7. Now let's see. One more 5 is there. In front there is 3, in back there is 7. This is also not considered. What is the rule? You should not have 7, but 7 is here. That's why. Next 5. Here is one more 5. Next to 5 there is 3, and before 5 there is 6. So which means there is no 7. So I have got third 5, which is okay with the rule. And lastly, there is one 5 here, which has 7 and 3. So I cannot consider. So totally how many 5s I got? 1. Let me change the color here. I got 1, 2, and 3. These are the 3 5s that I got, where the condition given in the question was completely satisfied. Okay. So the number of 5s are 3. Okay. So this is number test. You just have to see the data given and then check with the rule or condition given and solve the problem. Okay. I hope everybody is able to follow that. Now, let's go to the next question. How many even numbers are there? Here I am seeing the second question. How many even numbers are there in the following sequence of numbers which are immediately followed by an odd number as well as immediately preceded by a even number? So we have to find out even numbers. Okay, we have to find out even numbers. What are even numbers? 2, 4, 6, 8, 10, 12, 14, and so on. Okay, but if you see the numbers here, you'll only have 2, 4, 6, 8. Okay, so these are the even numbers. So they're asking us how many even numbers are there. I'll write it as E. Okay, with the condition. What is the condition? Immediately followed by an odd number. So after even, there should be an odd number and immediately preceded by an even number. So first you should have an even number, then an even number, and then an odd number. If you have like this, then you'll be able to consider that part. Now let us see the series. Now if you see the series here, the first number is a even number. 8 is a even number. Okay. But for this 8, is there an even number before and odd number after? We have to check. So 8 has a odd number is not there. It has an even number. So this will not work. Now let's check 6. Now we'll do one thing. We'll take 3 numbers and check. Okay. Now if you see here, we'll take 4 numbers and check. That also will do. Now we are checking the second number. Now for this second number, 6 is an even number. Next to 6 is 7. This is an odd number. Before 6 is 8, this is a even number. Correct? So I can consider 6. 6 is the first even number. Okay. Now let us move further. 6, 7, 6, 8. Now I am considering the 7. 7 is an odd number, so nothing can be done. 7, 6, 8, 9. See, I'm just taking the series here. I'm adding on 1, 1, 1, 1 number, or we'll do it there only. That will be better. So now 7, not possible. Now we'll go to the next even number. In next even number, again I have a even number, so not possible. If you take 8 here, it has a odd number, that is 9 is a odd number, and previously there is a even number which is 6. So even, odd. So I've got two numbers. Okay, which one? One was 6, one was 8. Two numbers, two even numbers we have got. Now let us continue. Now after that, see the next even number. Next even number is 2. It should be even, odd. Okay, so we'll this, if this is 2, before this there is 3, and after this there is 7. No, not possible. 2 is not possible. Then for 4 also not possible, because you have a even number and then a odd number, not possible. Then 2 also not possible. Take this 2, second one. If you see this 2, there is a odd number, that is 3, and there is a even number, that is 2. So we are getting even, odd as the combination. So this 2 is also considered. Now after this, let us see the next number. 2 is also not possible. See the next 2, not possible. 8 has an odd number and an even number here. So even, odd will work. So 8. So how many in total? 6, 8, 2 and 8. So we have 4 numbers in total. But since the option is not 4, we will write none of these. If you see the option, there is no option as 4. So that is why we will write it as none of these. But in the examination, explain this and write there are 4 even numbers. Okay. So this is how you will get the number test. They'll give you the numbers. They'll ask you what is front, what is back, what is the difference, what is all that addition, subtraction, multiplication will be given to you, where you'll be able to solve them easily. Okay. Now we can see one more question. I will solve it. That is the third one here. In the series, and they have given you all the numbers, how many pairs of successive numbers have a difference of 2 each? How many pairs of successive numbers? Successive numbers means next to next. Now 6 and 4, okay, 4 and 1, 1 and 2, 2 and 8, like this. Okay, they have a difference of 2. Now let us see how to find out. We will take the numbers one after the other. Now first two numbers, 6 and 4. So 6 minus 4 is 2. Correct? So we got the first pair, that is 6 and 4. That is the first pair. Now let's find out the next one. 4 and 1. 4 minus 1 is 3. So not possible. 1 minus 2 is minus 1. Not possible. 2 minus 2 is 0. Not possible. 2 minus 8 is minus 6. Again, no. 8 minus 7, 1. Again, not possible. 7 minus 4 is 3. Not possible. 4 minus 2. 4 minus 2 is 2. So 4 and 2 are the next pair. 4 minus 2 is 2. Then 2 minus 1 is 1. 1 minus 5 is 4. 5 minus 3 is 2 again. So 5 minus 3. 5 minus 3 is equal to 2. So 5 and 3. Then 3 minus 8 is 5. 8 minus 6. 8 minus 6 is 2. So 8, 6. Then 2 minus 1 is 1. 1 minus 7 is 6. 7 minus 1 is 6. 1 minus 4 is 3. 4 minus 1 is 3. 1 minus 3 is 2. 1 minus 3 is 2. So 1, 3. Then 3 minus 2 is 1. 2 minus 8 is 6. So 8 minus 6. Again 8 minus 6. So again 8, 6. So 1, 2, 3, 4, 5, 6. There are 6 pairs. You have answer C. There are 6 pairs where you will find the difference between all of these numbers to be 2. Okay, the difference between all of these numbers is 2. So this is the number series. They'll give you a series or the number test where you'll have to just add, subtract, multiply or square them and check the values. I hope it is clear to everyone. You can just write down the explanation, however it is given. Okay. Yeah. Coming to the last concept of logical reasoning, that is syllogism. Okay. Now in this syllogism, let's understand what is syllogism first. So syllogism is a form of deductive reasoning. Okay, it's a form of deductive reasoning where we arrive at a specific conclusion by examining the other ideas. So we will understand what is happening in the surrounding and taking all that into consideration, we are going to come to one conclusion. So that is known as syllogism. Now syllogism is a Greek word. Now this syllogism, Greek word, it means conclusion or inference. So coming to a conclusion or coming to a fair idea about what we are trying to say to the people, that will be called as syllogism. Now in syllogism, you'll have 3 major components. Now what are the 3 components? Firstly, major premise. Major premise means what is the major factor which is influencing us to come to the conclusion. Now minor premise. Minor premise is a supporting quality to make a conclusion and the conclusion itself. Now let us take this example. All roses are flowers. So that is a major premise. So we are saying all roses are flowers and that is accepted, right? And what is the minor premise? What is the root meaning? This is a rose. Now, when there is a general statement which says all roses are flowers, this is a general statement. Okay. Now, suppose if I am holding a rose in my hand, okay, so I say this is a rose and everybody knows that rose is a flower, right? So in return, I can also say I am holding a flower. Instead of saying I am holding a rose, I can also say I am holding a flower, right? So that is syllogism. There will be a general statement, there will be a specific statement, and by comparing both of them, we are going to give a conclusion. That is known as syllogism. So it's a form of deductive reasoning where we come to a specific conclusion by looking around or by looking the other ideas. So that is known as syllogism. Now let us see types of syllogism. So the types of syllogism that typically contain three components is called as categorical syllogism. What is that? Categorical, we have three categories, right? Major, minor, and conclusion. Okay, so that is called as categorical syllogism. If A is part of C, then B is also part of C. A is part of C means A is a general statement. Roses are flowers. A is a general statement. B, this is rose. C, I am holding flower. So if A is part of B, rose and rose, A is part of B, and if B is part of C, C is I'm holding a rose actually, but instead of saying I'm holding a rose, I will say I am holding a flower. Okay, so this is categorical syllogism. Let us see one more example. All cars have wheels. Agree? All cars, it's a general statement. All cars have wheels. I drive a car. So my car also should have wheels. All car has wheels and I drive a car. So what is the conclusion? My car also has wheels. See, the sentences may sound silly for you to see here and solve it here, but then the reason behind giving such question is to improve your understanding capability and your mind ability. So you are expected to be carefully read each and every sentence, because we are with all the social media and the distractions that we have, our attention span has come down, so we cannot concentrate for a longer period of time. Now let us concentrate here and understand what is it. So let's see one more example. All insects frighten me. So let's say A is a person who hates insects. He is very afraid of insects. Okay, we can say A is a person who is afraid of insects. Afraid of insects. Now A is saying all insects frighten me. I am afraid. I feel very scared. And he's showing that is an insect. Okay, so there is an insect which is there. So he's showing that insect, that is an insect. And I am frightened. So can you see? This is the major premise. This is the minor premise. And then this is the conclusion. All insects frighten me is a general statement. In that he is saying there is an insect and because of that I am frightened. So the conclusion is being frightened. Okay, so this is syllogism. So that was categorical syllogism. Now let us move further. Let us understand conditional syllogism. These are simple things. You'll be able to, they'll not give you separately as conditional, categorical and all. Simply they'll give you the questions for you to answer. Conditional syllogism follows an if A is true, then B is true. So this becomes a little challenging. If A is true, then B is true. So that is conditional syllogism. They are often referred to as hypothetical syllogisms because the arguments aren't always valid. So sometimes they are merely accepted truth. So let's see an example. If Katie is smart, then her parents must be smart. Now, can you definitely say, or can you 100% say, yes, Katie is smart because her parents are smart? You cannot say. Or you cannot say, parents are smart, so their kids will also be smart. You can never come to a conclusion so easily. So these are conditional syllogism. So here you'll have only two sentences or two main things. One is major premise, the other one is conclusion. So if KT is smart, if the first two, this is A, if A is true, then B is true. It's a pattern, but there is no rule that it should always be valid. It can also be wrong. Okay, so KT is smart, correct. But what is the conclusion? Because KT is smart, her parents also are smart. Here they are saying must be. Must be. We are not completely saying, definitely saying. But when it comes to syllogism, we are accepting that KT's parents are smart. Then one more example. Richard likes Germany, then he must drive an Audi. So what they're saying, Richard is a person who likes the country Germany. So just because he likes the country Germany, it doesn't mean that he drives an Audi car. Right? Just because he likes the country Germany, it doesn't mean that he likes or he drives the Audi car. So Richard likes Germany maybe for food, maybe for the lifestyle, maybe for the language. There can be many other things. So you cannot 100% say this is correct. It can also be wrong. So what can you conclude here? You can conclude saying Richard likes Germany. He must like all things including cars. So we are giving an option. He's liking all things including car. We are not saying he is driving an Audi. Okay. So this is conditional syllogism. There is a condition. If one part of the sentence is true, the other part will also be true, is the notion that they have. So understand conditional syllogism. If A is true, B is true. Okay. So this is conditional. Now let's move further. Disjunctive syllogism. Now here, read this carefully. Since A is true, B must be false. So you'll have one positive statement, one negative statement. So if A is true, B must be false. So here they will, not think too much. So they don't state if a major or a minor premise is correct, but it is understood that one of them is correct. So here they'll give you two sentences. Both can be correct, both can be wrong, one can be correct. But nobody is considering that. It is just understood. It is just thinking, with just you're thinking that yes, one may be correct. And one more important thing in logical reasoning, please do not put any of your thoughts, your beliefs into the question. Now take this example. This cake is either red velvet or chocolate, and minor premises, it is not chocolate. So sometimes you'll have a red velvet, chocolate both together. So don't put your views into the question. Just follow the question, just follow the information given and try to answer it. Okay, so that is very important in logical reasoning. So this cake is either a red velvet or chocolate. Minor premises, it is not a chocolate. So what is the conclusion? The conclusion is this cake is a red velvet cake. We are saying it is a red velvet or chocolate. So if it is not a chocolate, it means it is a red velvet. There are two options. There are two options. What are the two options? Red velvet, chocolate. If it is not a chocolate, it means it is a red velvet. If one is false, the other one is true. Okay, so that is how we do it. Now let's see one more. On a TV show Outlander, Clary's husband is either dead or alive. So that is the main sentence. Now, under that, he is not alive. So, on a TV show, Clary's husband is either dead or alive. There is no definite answer. Now, what they are saying, minor premise, he is not dead. If he is not alive, he is not living, which means Clary's husband is dead, will be the conclusion. They have given you two options, dead or alive. In this, they are saying this option is not there. It means this option you have to choose. Okay, so that is syllogism. And we understood in syllogism, categorical syllogism, conditional syllogism, and disjunctive syllogism. So these are the things we understood. Okay, so these are not part of your okay, we'll just understand the rules of syllogism and solve few problems. So there are 6 known rules of syllogism. However, they may apply to categorical syllogism since that is the only category that requires 3 components: major premise, minor premise, and conclusion. Okay, so these are the 6 rules. Let us see. Rule 1. There must be 3 terms: major, minor, conclusion. So we have understood what are these: major premise, minor premise, and conclusion. Then the minor premise must be distributed in at least one other premise. So the minor premise, that is the second part, whatever you're seeing here, this has to be distributed in one of it. Either in the major or in the conclusion, the minor premise has to be distributed. Okay, the words will be repeating in the major premise or in the conclusion. Then any terms distributed in the conclusion must be distributed in a relevant premise. So when you are taking the premise to the conclusion, you have to make sure that it is taken in a proper way. If not, it will give a very weird meaning. Then do not use two negative premises. So both the premises should not be negative. One should be positive, one should be negative. Okay, or both can be positive, but both cannot be negative. So you have to keep that in mind. Both syllogism premises cannot be negative. Then if one of the two premises are negative, the conclusion must be negative. So if you see the question here, which we saw, on a TV show Outlander, Charlie's husband is either dead or alive. Here there are options. Dead or alive are the options. But what is the conclusion? Conclusion is negative. It's a negative statement. Clary's husband is dead is a negative statement. So if one of the premise is negative, the answer will also be, or the conclusion will also be negative. Then from two universal premises, no conclusion may be drawn. If you only give information, you cannot draw the conclusion. So these are the 6 rules of syllogism. Now let us solve few problems under syllogism. We will be able to understand. Now every question will be given the conclusions. Okay, and we are supposed to find out, or we are supposed to select if only one conclusion follows, if only two will follow, if either one or two follows, if neither one or two follows, if both will follow. So these are the fixed options here. Now let us see the statement. Some actors are singers. Some actors are singers. All the singers are dancers. So some actors are singers. All singers are dancers. So this is what they're saying. Now let us use a Venn diagram to understand this. Some actors are singers. So singers is a bigger circle. Okay, this is singers. And if you see here, some are actors. Some actors will act also, they will sing also. Okay, and then all the singers are dancers. Now all the singers are dancers. So what is the conclusion? Let us see what is the conclusion. The first conclusion, some actors are dancers. See, if you see here, some actors are singers, all the singers are dancers. So I can also say some actors are dancers also. Correct? I can say that some actors are dancers also. That is your first one. Now the second one, no singer is a actor. Or yeah, we can use such Venn diagrams which will be easily used to solve the problem. So the first option is some actors are dancers. I'll write it down here. Some actors are dancers. Now let's take for example, these are singers. All singers are dancers. Few actors are singers. Few actors are singers. So I can also say few actors are also dancers. Right? I can say that also. So my first conclusion is correct. Now the second conclusion, no singer is actor. Now no singer is actor I cannot say, because if you see here in this circle there is a small circle which says actor. So I cannot say this. So no singer is actor is false. This is false and this is correct. So what is my answer? Only one conclusion follows. Only the first conclusion is correct and only one conclusion follows. Okay, so this is how you solve the syllogism problems. It's always best to use the Venn diagrams to solve the syllogism. Now let us go to the next question. All harmoniums are instruments. All the instruments are flutes. So all the harmonium, let me take, okay, these is harmonium. This is harmonium. All the harmonium are instruments. Okay, all the harmonium are instruments, which means in a bigger circle of instruments I have harmonium. Okay, all harmonium are instruments. And then all the instruments are flute. So which means in a bigger circle of flute all the instruments are there, and in this instrument circle there are harmoniums. Okay, so that is what it means. Let me do that again. All the harmoniums are instruments. This is instruments. All the instruments are flutes. Okay, all means, now see, this circle is already included. So which means what all will come here, no? Everything will be included in flute. That is the statement. Now let us see the conclusion. All the flutes are instruments. All the flutes are instruments. You cannot say that. All the instruments are flutes, you can say, but all the flutes are instrument, you cannot say. Okay, so you cannot go with this always. Then all the harmonium are flute. You can go with this. See the circle. See the circle inside. All the harmonium are flute. So the harmonium is in a small circle inside flute. So second one, you can say yes. But the first one, you cannot say yes. Because all the flutes are instrument. If you had flute and then instrument, then you can say first one is correct. Now, since it is not there, first one is wrong. Only second one is correct. So only second conclusion, that is all the harmoniums are flutes. Only this is correct. So option B is your answer. I hope that is clear to everyone. One more problem we shall do. Yeah. Some mangoes are yellow. Okay. Some mangoes, some, only some. So let us say this is mango. Some mangoes are yellow. So some, only few of it. Only some mangoes are yellow. And some tixo are mangoes. Okay, I hope that's how we pronounce it. Okay, some tixo. This is Tixo. Some tixo are mangoes. Fine. So let's see the conclusion. Now the conclusion is some mangoes are green. Some mangoes are green. Tixo is a yellow. So they're saying some mangoes are green, maybe. Because only some mangoes are yellow, so some mangoes may be green. Possibility. But if you see here, Tixo is a yellow. Tixo is a yellow means what you can do is you can, instead of writing Tixo here, you can also write like this. Mango. Few mangoes are yellow and Tixo is a Tixo. Tixo is what? What was that? Some Tixo are mangoes. So some Tixo are mangoes. That is also covered. Look here. Some Tixo are mangoes. And some Tixo are yellow also. Some some mangoes are yellow. Some mangoes are green. This is a possibility. This is also a possibility. So both 1 and 2 are correct. Once again, some mangoes are yellow. Some mangoes are yellow. Some tixos are mangoes. This is tixo. So some tixos are also mangoes. So what is the conclusion? Some mangoes are green. Okay. Apart from yellow, there can be green also. And tixo can also be a yellow. Some tixo are mangoes, right? So mangoes can be yellow. So tixo can also be a yellow. So that is option D, both 1 and 2. Both the conclusions are correct. Okay, so this is syllogism. You can solve few more problems which is given under this, which I'll be sharing in the group. I hope that is clear to everyone. So this completes our business mathematics and logical reasoning subject completely. Okay, so now it's your job to practice more and perform well in the exam. All the best to everyone.